Hi, in the last class we have seen what is accuracy, precision, and the stuff related to the errors and all. Actually, I thought of solving problems, but before getting into the problems, what I have seen the questions related to JEE or NEET. So we need to complete errors related to vernier calipers and screw gauge. So today our topic is errors in vernier caliper and screw gauge. So let us see what are the errors that we see in vernier caliper and screw gauge. So vernier calipers and screw gauge. So this is your vernier calipers, right? So in the vernier calipers, if you look, these are the two jaws. When two jaws engage, we should see this 0 of the vernier scale is aligned with 0 of the main scale. Now if this is not engaged exactly, if 0 of the vernier scale is not engaged with the 0 of the main scale, then it means there is an error. So let us see now. So you see here, it is clear that 0 is engaged. This is your main scale. It's already written here. So this is your vernier scale. 0 is engaged with 0. Right? Here we can see this is 0 is engaged with 0. If this is not engaged such a way, then we say there is an error. Now let us see. So this is your main scale. Okay, let this be your main scale. This is your vernier scale. Now you see here clearly, when two jaws are engaged, these two jaws are engaged, but you find that there is a misalignment. So you find that there is a misalignment between 0 of main scale and 0 of vernier scale. Right? This is your main scale and this is your vernier. So if you see here, 0 is here and 0 is here. There is a misalignment. This 0 and this 0. Some gap is there. What exactly it means is, if two jaws are engaged, exactly if 0 is not matching with the 0 of the main scale, 0 of the vernier scale is not matching with the 0 of the main scale, what do you mean by that? There is an error now. Already it is showing some reading, vernier scale is showing some reading. So how to compensate this error now? So let us see. So this is your main scale and vernier scale where they are engaged without error. Now with error, we can see here, this is the error, right? So here you are able to see the error. When the main scale and vernier scale are not coinciding, the zeros are not coinciding. This error is known as 0 error. This error is known as 0 error. And now, how much the error is? That is crucial now. Suppose if this orange exactly coincides with this orange line, like this, if it coincides, then already we discussed in the previous class, what is this first division and this first division, how much difference there will be? 0.1. So if least count is 0.1 mm, then the difference will be actually 0.1. Actually, if these two coincide, this practically it would be here, right? This first division would be here, and this gap, whatever the gap should be there, so there will be 0.1 mm. So keeping in mind the least count is 0.1 mm, or I would say the first division of the vernier scale and the first division of main scale, the difference will be 0.1, and second division it will be 0.2, third division it will be 0.3. That's what we have discussed. Now in this case this is not coinciding, so let us see which one is coinciding. Here I can see the second one is coinciding. What I mean by this is, already this has been advanced, this vernier scale has been advanced in this direction. How much it is advanced now? This gap is equal to how much? Because second division is coinciding. What is the error now? This error is 2 divisions into whatever the least count. I told least count is 0.1 mm. Even if it is the other value, whatever it is, 2 into whatever the least count of the vernier calipers is there. So 2 into least count, that is equal to, this is the error. That means actually if 0 coincides with the 0, then this should be on the other side, this should be on left, but it is actually advancing and it is showing 2 reading on the vernier scale. So your vernier scale reading is already 2, but actually it should be 0, but instead of that it is showing 2. Now this 2 into least count is the error. But what error is this? Because if 0 coincides, for example, if 0 exactly coincides, what is the reading? Reading should be 0, but it is actually showing 2. That means it is showing excess reading. Excess reading means this error is positive. Excess reading means this error is positive. So from here I measure something. Actually when two jaws are joined like this, when two jaws are joined, it is showing some reading, which ideally should be 0 coinciding with 0. So when I move this vernier scale, for example, I get some reading now. So now what is the point here is very simple. The logic is, now this already engaged with second division. So that means it is already showing this much excess reading. So what is the actual reading now? Actually, for example, I am getting some value. Now with this I will continue. And I get some main scale reading. And I get some vernier scale reading. So what is the actual value now? Main scale reading plus vernier scale reading into least count. This is the total measured value now. But already there is an error which advanced through, in this case, 2 into least count. That is already advanced. Now whatever the value I measure, I get excess of this value, right? So this value I am getting, in this value, whatever the value I am measuring in this is including this 2 into least count. This is an excess value because already there is an error of 2 into least count, which is already showing some excess measurement. Now this value minus the excess value. Excess value is how much now? This is the error. So error. This value minus error, because this error is excess. So that's why, because it is excess, we are getting extra value. That's why this error is positive error. So let us make it clear now. So it's very clear now. This I told you, because which ideally should be 0. We are having 2 on the vernier scale, which is an error. So whatever you measure, it is taking reference as to, right, from this the scale is moving. From this the scale is moving further. So suppose if I get a coincidence of, for example, next I move further vernier scale. I suppose sixth division coincides. What exactly coinciding is, if 0 is exactly coinciding with the 0 of the main scale, then ideally sixth division is not coinciding, fourth division is coinciding. But here, because already it advanced the second division, because this is already there, from there it is moving 4 positions. You are able to understand now? So ideally what is happening, if sixth division is coinciding, so already 2 is there which is advanced, therefore sixth division coinciding means 6 minus 2, actually 4 is coinciding. That is a simple logic. So that's why error, whatever the error is there, that we are subtracting to get the actual value. So second division is, this is the second division, which error, considering it as a 0.1 mm least count. If least count is other value, obviously it will change. 2 into 0.1 is 0.2 mm in this case. So there is a least count, 0.1 mm being least count. So 0.2 mm extra value you are getting. That's why this is a positive error. So this is, what error is this? This is a positive error. Very simple. If this 0 coincides with main scale, then second division whatever there, it should be on the other side. But it is advancing. As it is advancing, this advanced through 2 divisions, that is 2 into least count, and second one is coinciding. That means now this you taking as 0. Very simple. Now this becomes 0. From there whatever it advances, that will be there. For example, sixth division is coinciding. Now taking second as 0, sixth division means 3, 4, 5, 6, 4. 6 minus 2, that is fourth division is actually coinciding. It's very simple. Suppose instead of this error, in this case it is second division. For example, if third division is coinciding, if error is, in that case what happens, error is 0.3. That means 3 will be the vernier scale whatever coinciding, that 3 will be 0, and sixth division is coinciding after I make a measurement. So that means exactly instead of 6, third is coinciding. That means because already 3 divisions are advanced, so sixth coincides means 6 minus 3. Actually it should be third coinciding. I hope it is clear now. So positive error means you are getting extra value. Whatever the measured value I get extra. From that extra, how much is the error is there? Whatever the error is there, I have to subtract that error. So actual reading is measured value minus error, because error is positive, extra value I am getting. So in this case it is 0.2 mm. So similarly here in the previous case you have seen positive error. Positive error means extra value you are getting. So whatever the measured value is there, from that you have to subtract the extra value to get the actual reading. Now the reverse of this is, the reverse of the previous case is negative error. You see here 0 has been advanced, this is the main scale, and if you look at this, 0 is not coinciding, it is actually on the other side when 2 jaws are engaged. This error is known as negative error. We see what is negative error now. What exactly means is, for example, if this advances, if jaw advances, see if jaw advances, let this coinciding with 0. If this advances, jaw advances, what I mean is, I'll get some gap here, right? It will be ideally like this. Ideally like this. So my jaw will be like this. So what it means is I get some gap. So even though, so by the time 0 coincides with 0, that is main scale, this is vernier scale, When 0 coincides with 0, if it moves, that means already I am getting some gap. What do you mean by that? Even though reading is 0, there is some value here. Some gap means some value. So what exactly this means is, for example, from 0, then it moves to, for example, I move it further. The vernier scale, it moves, for example, like this. Move this. And after moving, suppose something coincides, maybe 7th division here, whatever it is coinciding, 7th or 8th, whatever it is coinciding. Let this be 7th division. Coinciding. That means it is not 7th division. Actually, it should be more, because what is happening is, so even though there is gap, we are showing 0. For example, after that 0, if it moves and first division coincides, so that actually gap plus first division, it is coinciding. That means whatever the measuring value is there, for example, you are getting first division, but actually it should be more divisions, because the 0 is here, and if it advances and here it coincides, then by the time there is some gap. That gap is error. But what error is that? What error is that? Suppose if it is 0, already there is some value, but I am showing 0. Suppose if it 1 coincides, that means already some gap is there, plus 1 is coinciding. So I have to add that gap, right? So whatever the error is there, that is negative. That means whatever the measured value is there, whatever the measured value or measured reading is there, that actually is less than the actual value, because 0 is already this side. By the time it coincides with 0, already there is some value, and further it is increasing. So this gap, whatever is there, by the time 0 coincides with 0, that already is there, but which we are not getting in the measured value, that has to be added now. So whatever the measured reading I am getting, less value, and actual value is more. Actual value is more. You are able to understand? Here the main scale is there, here the vernier scale is there. By the time it opens, it slides towards right, vernier scale, already jaw opens. That means already there is some gap, but you are getting 0. Even though there is some reading, you are getting 0. That means your measure value is 0. It shows 0. That means there is nothing in the jaws, but there is some gap in the jaws, which means you are getting 0 as a measured value, but there is gap in the jaws. That means the value whatever you are seeing is less than the actual value. Similarly, first one coinciding, actually it is not first one coinciding, this gap plus the first one. So your measured reading is less than the actual value. That's why this error is negative error. So let's see now practically how it is. So this is, see, in the earlier case, the 0 of the vernier scale was on the side, right? But here the 0 is on this side. So when it slides, for example, if vernier scale slides like this and this orange coincides, by the time there will be some gap here. So which is error now. Now let us see, this is on that side. Now the point is how to find this negative error. In the earlier case, we have seen whichever the division, that is vernier scale division is coinciding, that is the error, and we are simply subtracting that because we are getting excess value. But here it is slightly different. Try to understand now. Now actually this is moving in this direction. So ideally, if 0 coincides with 0, this 10 will be here, right? It will be coinciding here. This 10 will be here. So since it is on the other side, now let's see which division is coinciding. So here in this case, first, second, third, 4, 5, 6, almost 7th is perfectly coinciding. Let this be 7th. So 7th is coinciding means you are supposed to take from this side here. It is actually advancing from here. So that means this first division actually should have this one. This should have coincided with this, and the gap what you see here should be, in ideal case I am talking about, 0.1 mm. This gap what you see between should be 0.2 mm, and ideally here it should be 0.3 mm. But since it's advancing and third division which supposed to be here and it is advancing and it is coinciding, so how much the third division moved now? 0.3. Whatever the case we see from the forward side is same, right, from the backward. So now actually seventh division is coinciding, but how much this has moved in the negative direction, that is in this backward direction. This backward direction it is exactly moved. Third division from the backward it is third division. From backward it is third. From forward, even though it is 7, from backward it is third. So how much has moved towards left is third division into least count. Assuming it is 0.1, it is 0.3 mm. It has moved in this direction. Now, very simple now, when this vernier scale opens up and 0 coincides 0, by the time how much already the gap is there? By the time this gap is there. This gap. So, if it moves and 0 coincides, so whatever 0 is there, if it moves and coincides with, by the time this gap, it would have made a gap of 3 into least count. Very simple. Because why into 3 into least count? Because this is moving in this direction. This gap, whatever you are able to see, is actually whichever the division is coinciding. Third one is coinciding. That means 0.3 mm it has advanced. So 3 into least count otherwise. So 3 into least count has not advanced now. So when 0 coincides, if I move this, 0 coinciding with this, by the time already 3 into least count has been opened. But whatever the value I see, it's only 0. Now from that 0, suppose, then fifth division is coinciding. Now this coincides with 0, by the time already I am seeing this gap now. Then after that, I am moving this scale further and fifth division is coinciding. That means this already there, this gap, plus 5 into least count. This is coinciding. That means my value in the earlier case, in the positive error case, what happened is whatever the measured value is there, that you are getting in excess. Even though you are coinciding sixth division, already second division is, whichever is second division is already coinciding. That's why that is taken as 0. And after that, when sixth is coinciding, 6 minus second division, actually fourth should be coinciding. In this case, it is reverse. Now already by the time 0 coincides with 0, there is some gap, and that gap is equal to how much? 3 into least count, considering the 7th division is coinciding. And after that 5th is coinciding, that means 5th division is coinciding plus this is shortage now. This has to be added. Now this error, whatever the measured value you are getting is less than the actual value. Less, you are getting shortage. That's why this is negative error. And how to calculate this? This is very logical now. So how is this logical now? Actually, whatever the gap it is left out here is 3 into least count. This gap, by the time it coincides. Now that has to be added. So, but practically in this case, we are able to see the scale. We can find, and logically we can think, we can solve the problem. But if it is mentioned that there is error, suppose in a question if it is mentioned that there is an error in vernier calipers, how you know whether it is backwards or forward? That means whether it is negative error or positive error. It needs to be mentioned whether it is a negative error or positive error. Otherwise, simply if it is error, we don't know. In this case, we can understand. Looking at the scale, okay, this is negative error. And if 0 is on the other side of the main scale, it is positive error. Looking at the vernier calipers, we can understand. But simply in the question, if it is mentioned it is an error, then we cannot solve the problem. It should be clearly mentioned that whether there is a positive error or negative error. Now it is clear now. Now this is negative error. Now how to find the error? Practically I have shown you, because this third division from backward it is coinciding. That means exactly this 0 has moved through 3 into least count. This is all okay. This is all logical. But simply in the question if it is mentioned that 7th division is coinciding, then what is the error? So that's why here it is 7th division is coinciding. Very simple now. 7th division is coinciding. And what are the total number of divisions? Minus 10. So into least count. This is the error. Very simple. Now minus 3 into least count. So you are getting some negative value, minus 3 into least count. Assuming it is 0.1 mm, least count 0.1 mm. So minus 0.3 mm. So error is minus 0.3. Measured reading or value, whatever it is, measured reading. So error has to be added. So that should happen mathematically. We should not think whether we have to add or we have to subtract. So that's why it's very simple now. Whatever the negative value we have seen, minus error. So measured value minus error means, in this case we have seen minus 0.3. So it automatically adds up. So the logic is very simple. So how to find the error now? Error means whichever the division is coinciding division, that is from forward in this direction. No need to think of backward and all. Just for understanding, I told you how actually what is this value. So I am taking the coinciding division minus total number of divisions, on vernier scale into least count. This will give the error if it is a negative error. Very simple. And automatically minus error, it will be negative value. Automatically this will add up. This becomes plus 0.3. So measured value. So what is happening is very simple. Whatever the measured reading you are getting here is shortage of the actual value, because your vernier scale is behind. So by the time it coincides, already the jaws are open. How much jaws are open? That has to be added. The jaws are opened by 0.3 mm in this case, considering least count as 0.1. I think very simple. After that, if fifth division coinciding, it is exactly what's now fifth division plus already 0.3. So 3 divisions, it is backward. So by the time it comes 3 divisions plus fifth is coinciding, 5 plus 3, 8. Eighth division is exactly, that's how you're compensating the error, or I would say you're correcting the error in a vernier calipers. You're getting the correct value with error in a vernier calipers. Okay, I hope it is clear. Let's see. So here 7th division is coinciding. So this is the error which is backwards now. So this is a negative error. So error is 7 minus 10 into least count, which is negative minus 0.3. So suppose the actual reading is measured value minus error, measured value plus 0.3. That's what happens. If you want to see again, measured value plus 0.3 mm. So similarly, in order to understand the concept clearly, just try to understand here. This is a weighing machine. Suppose I want, just consider this as a measuring instrument now. So I put some vegetables or whatever it is. I put some vegetables here. I want to weigh it. I want to find what is the weight of the vegetables now. So this is perfect now. Suppose I put 1 kg actual value, it is measured value is also 1 kg because it is balanced. Suppose it is like this, where already this is an error now. This side it is showing more, even though there isn't anything put in the vessel. It is, even though it is empty, both sides, no weight here, it is empty. But since there is an error, the scale is already, the pointer is already onto the right. Now, suppose if I put some 50 grams here, suppose here I put some 50 grams, I am adding. Then if it balances, that means, what do you mean by this? Even though there isn't anything, it is showing. So even though there is anything, nothing is there. 50 grams, when I put 50 grams, it is showing 0. That means this value, there isn't anything now, but it is showing 50 grams. So what is this? This is similar to the positive error what you have seen in vernier calipers. Even though there isn't anything, it is showing some value. So now suppose I want to weigh some vegetables. I put, and here instead of I put the vegetables here, I am dropping vegetables and I am measuring, I am getting 1 kg balanced. So what do you mean by this? But actual value is how much now? It is not 1 kg because already 50 grams here, it is showing excess. It is showing excess. So 1000 grams, 1 kg means 1000 grams minus 50 grams, that is 950 grams. So the measured value is 950 grams. That means even though it is balancing for 1 kg, there is an error of 50 grams. That is, even though there is nothing, it is showing this side, it is already having some more weight. So 50 grams it is showing. So that means if I drop some vegetables and I measure it as 1 kg, actually the weight of vegetables is only 950 grams. This is exactly the positive error in vernier calipers. In vernier calipers is showing excess value, that's why you are subtracting the error, whatever the error is there. Similarly, this is your negative error. So the pointer, if you see here, it is actually onto the left side. So it should be ideally like this, right? Your pointer should be, but it is slightly onto the left. That means both sides it is empty, but this side it is showing some, this is inclined towards this one. So this is negative error. So what do you mean by this is, if I drop, let this be, I am dropping some 50 grams here. After dropping 50 grams, if the pointer is balanced, that means this side there is an error of 50 grams. So even though I am putting 50 grams, it is just balancing, it is showing 0. That means this is negative error because it is showing shortage, right? This value is showing the measured value. Let this be a measuring value here. It is actually showing 0, but where I am dropping 50 grams, this value, measured value is showing less value or less reading. So this is a negative. So now what happens if I drop the vegetables here and measure, this is 1000 grams, that is 1 kg. Actually, what is the weight now? Because already for 50 grams it is balancing, and for 1 kg it should be 1 kg plus 50 grams. That should be ideally the vegetable says, even though this is the measured value, this is the measured value of 1 kg, but ideally what is the actual weight of the vegetables now? 1000 grams, that is 1 kg plus 50 grams. So 50 grams is negative. That is negative error. That means your measured value is less than the actual value. Your measured value is 1 kg, but actually there is 1 kg plus 50 grams. So that 50 grams has to be added. This is similar to the negative error in vernier calipers. And the same will be holds good, and whatever the concept is there, the same will hold good for screw gauge also. Let's see what are the errors in screw gauge. So this is spindle, this is anvil, there isn't any gap. So in this position, what exactly, if ideal condition, if it is perfectly working and without any errors, screw gauge is there, then the 0 of the circular scale should coincide with the center line of the sleeve or center line of the main scale, whatever, center line I would say. Now assuming that there is an error now. So this is your actual scale without any error. Now assuming an error, So this is without any error. Assuming an error now, 0 of the circular scale is coinciding with the 0 of the center line. Very simple. Now let us see. Now see, 0 of this circular scale is not coinciding with the 0 of the sleeve. That already it is, what is the value now? It is second division, 0, 1, 2. Second division in this case. You can see here. This is your first division, this is your second division. 1, 2, 3, 4, 5. Okay. Second division is coinciding with 0. So, but annuality here it is closed. There isn't anything. There is no gap. Nothing is there. But it is showing 0, 2 on circular scale. That means what error is this? Positive. Yes, it is showing some excess value. So, what is this excess value now? 2 into 2 into least count. You are able to understand? So, this is a circular scale and second division is coinciding. So, that much it is actually showing. Okay. This is excess value. This is excess. That's why this error is known as positive error. This error is known as positive error. Okay. Let's see now clearly. So this error is second division is coinciding. So this is a positive error. So error is 2 into least count. Assuming the least count is 0.01 mm because there are 50 divisions here. Assuming the main scale division, that is the smallest division I can measure on this main scale, that is 0.5 mm. So this becomes 0.01 mm, which I have seen in the earlier case. So now actual reading is equal to measured value minus error in this case. So very simple, you are getting excess value, so that now this becomes 0. Very simple. What is the concept here? Now take this as 0, this as 0, second one as 0, and after this you is rotating. Suppose from second, 10th one is coinciding. That means actually it is showing 10th one. The reading here, whatever the reading you are able to see, that is 10th one, but actually how much it has moved through? From 2 to 10, that is 8. 10 minus 2. Only 8, but it's showing 10. Therefore, whatever the reading you are able to find with 10, that has to be subtracted finally. Subtracted how much? This should be 2 into least count. This is subtracted. So this value is the actual value. It's very simple. Similarly, this is positive error. Now we go to negative error. So this is without any error. Without any error, you can see. So error C, the same here. Now 0 is already here. That means you are rotating in this direction anti-clockwise from here. I am opening the thimble. So by the time 0 coincides with 0, if I rotate, there will be some gap here. Similarly, what I have seen in vernier calipers. Now there will be gap. How much gap it will be? If 0 coincides with 0, how many divisions see? 1, 2, 3, 4. Since 46th division is coinciding, after that if I open 1, 2, 3, 4. So 4. So if 0 comes here and coincides, by the time how many divisions it is? First 2, 3, 4 divisions. 4 divisions it is moving. By the time 0 comes. So already there is some gap now. So what error is this? Negative error, because there is some gap, but you are showing 0. So now what happens? From 0 further, I am measuring some value, and from 0 further, now what is the 0? 0 is in this case, this is the 0. 46th one. 46th division is 0. From there you are going to 5, for example, and 5 is coinciding while measuring. Actually it is showing 5, but how much it has moved now? So this 4, by the time 0 coincides, plus 5. This 4 plus here 5. So total 9 divisions. It has advanced. That's why what is the error now? 4 into least count is the error which has to be added because you are getting shortage. Because by the time 0 coincides, already there is some gap between anvil and spindle. That is a shortage value. By the time it goes to 5, actually how much has moved? 4 plus 5, ninth division. Exactly ninth division has been coincided. That's what it means. Now, here, similar, the same concept what you have seen. What is the error now? Error is negative. And how to get this? 46th division is coinciding. 46th division is coinciding. This is 45, 46th division is coinciding. 46 minus 50, the total number of divisions on circular scale, into least count. So what I get is minus 4 into least count. This has to be added. Very simple. So let us see now. So what is the division? 46th division, 45, this is 46. This error is negative error. So error is minus 4, so negative error, this shows a negative value. So very simple now. So instead of, because examining screw gauge, I can find, okay, how to logically do this, because 46th division is coinciding and I understand this error has to be added. But if simply in a theory question, if it is mentioned that there is an error in the screw gauge, it has to be clearly mentioned whether it is a positive error or negative error. And which division is coinciding. We cannot say from backwards it is 4, nothing like that, right? So 46th division is coinciding. And negative error. That means 4 divisions it is backward. That exactly it means. So 4 divisions are to be added to the least count. So this is the error. 4 into least count. That is to be added. So negative error you are getting. So automatically your measured value minus error, that becomes positive, which happens to be added to the value. So error, measured value minus. So this becomes this. Okay, this is about errors in vernier calipers and screw gauge, which I felt very important for solving IIT, JEE or NEET questions, whatever, or any other competitive exam. So when I have gone through the previous questions, that's what I have seen. So in the next lecture, I'll cover the questions.